Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, so I hope you guys are well enough, okay, and still have the energy, okay, to continue our lecture. Okay, so today we will be continuing from where we stopped yesterday. And okay, with me today, so we're going to have two special guests, okay, that will join us this morning. So let me introduce you. Okay, Shamin from S125 and also Nob from S125. Okay, so throughout the discussion, okay, so if Nob and Shamin, if you have any question, then we can discuss throughout the lecture. Okay, so are you guys ready?
Yes, we are ready. Saya ready.
Ready, all right, okay. So now let's discuss this topic. Okay, so can you hear me now? Okay, sorry. Ya, Syed Ali tak dengar suara saya tadi. Ya, okay. Good morning, Bon. Good morning, Alia. Okay. Alright, so sekarang dah dengar ke Hamzah? Boleh, alright. Okay, thank you, Abby. Okay, morning, Akil. Okay, so Liana says hi to Shamin and Nob. Excited nampak kawan dekat YouTube live kan? Dia baru semangat nak belajar bila kita nampak kawan kita. Okay, so kalau boleh saya nak masukkan semua, tapi because StreamYard is quite limited, we can only have 6 guests. Okay, so kita jemput sikit-sikit dulu So next week saya akan jemput daripada praktikum lain pula. Okay, then baru kita baru lebih semangat lah. Okay, kita nak belajar. Okay, so now, okay, I'm going to again share the screen. Okay, so we will be discussing this. We are going to find all the measures here: mean, mode, median, quartiles, and percentiles for first ungrouped data. And then for the next one, we are going to find mean, mode, median, quartiles, and percentiles for group data. Okay, and then here we are going to construct and interpret box and whisker plot for ungrouped. Okay, so in your syllabus, we do have only box and whisker plot for ungrouped. We don't have any box and whisker plot for group data. Okay, so these are the measures or the measures that we are going to find and in order to plot our box and whisker diagram. Okay, so now let's begin. Okay, so mean, median, and mode of ungrouped data. Okay, so we do have formula. All right, and before we begin, so I just need to let you know this topic 6, data description, will be covered in both UPS, okay, UPS 3 and group assignment, okay, topic 6 and also 7. Okay, so since they are covered in both UPS and assignment, so which means this topic won't be covered in PSPM. Okay, so once you understand this topic and you can do your UPS and group assignment well, okay, then you may just focus on other topic. Okay, so Alright, so now let's start. Okay, so mean of a set data is written as x bar. Okay, and is defined as this. Okay, so the x bar or the mean is basically the sum of all data divided by number of data that we have. Okay, so the formula, so you just find the sum of all those data that you have and then you divide by the number of data. Okay, so this is the formula. Yeah? Okay, I'm sure you know how to find mean. Okay, for example here, okay, so find the mean of a set of numbers. So this is given as ungrouped. Why ungrouped? Because you cannot see any interval here, right? So there's no interval. Okay, so that's why, okay, we can say that this is ungrouped data. Okay, so how to find the mean? So first you just sum all of these values. Okay, you just find the sum of all these values and then you divide by, okay, how can we get 7 here? You just calculate the number of data that we have. So now we have 1, 2, 3, 4, 5, 6, and 7. So altogether we have 7 data. So sum of all the numbers here give you 39 divided by 7. So this is the mean value. Okay, and every time we need to finalize answer, we just give correct to 3 significant figures. Okay, and then second example, find the mean of a set of data. Okay, so we can see that this is also ungrouped. Okay, why ungrouped? Even though you can see a table here, even though it's a table, but okay, it's table without interval. Okay, so table without interval is still considered as ungrouped data. Yeah? Okay, so it's still considered as ungrouped data. Okay, so we'll be using the formula to find the mean. Okay, so here we are having number of male children. Okay, so frequency means for the families, number of families. Yeah, so number of male children. So there are 2 families which, okay, don't have any male children, and here there are 5 families which have, okay, which have only one male child, and there are 7 families who are having, okay, 2 male children, so on and so forth here. Okay, so we can say that, okay, in order to find the sum of all data, so we need to multiply the frequency here or the number of families with the number of male children. So in this case, so we just multiply. Okay, so this is what we can call as x. Yeah, okay, so the data that we have, okay, multiplied by the frequency. Okay, so here you have 2 times 0 plus 1 times 5 times 1 plus 7 times 2 plus 3 times 3 plus 2 times 4 plus 1 times 5 divided by the total frequency. So the total frequency or the number of families, so we can find the sum of this. So you will have 41 over 20, which is 2.05. Okay, so this is basically how to find mean for ungrouped data. Okay, so now let's see median. Okay, so median, okay, what is median? Median is the middle value. Okay, so median is the middle value when a set of data is arranged. Okay, so again, I need to repeat here. Okay, median is the middle value when the data is arranged. Okay, so the idea is before you find the median, please make sure that you arrange the data. Okay, and then we choose the middle point. So for example, for a set data arranged in ascending order, so there are 2 cases. When the data is odd, then the median is in the location n plus 1 divided by tooth observation. When the data is even, the median is the mean of n divided by tooth value and the n over 2 plus 1 value. Okay. I would like to introduce this formula. So in order to find median, so we can also use the formula of percentile. Okay, so I'm not sure whether you have heard of this term before, but percentile is basically derived from the word percentage. Percentage means, okay, so we can see that, for example, if we have 10 percentile, okay, so it tells that, okay, there are 10% of data, okay, which is less than the 10 percentile value. Okay, which is less than 10th percentile value. Okay, so that is how we interpret. Okay, so percentile, it comes from the word percentage, and we do have formula. And because we know median is basically middle value, right? So okay, we know that the total of percentage is 100. Okay, so when we talk about median, so we are looking for 50th percentile. So how we pronounce this? So this is 50th percentile. Okay, And yeah, how are we going to use this formula? Okay, so this is the formula which is commonly used in exam. Okay, so usually the exam board will provide you this formula. Okay, so we can see the formula here. So the formula of percentile, if okay, we have xs plus 1 divided by 2, given that s is element of. See the symbol here, this is element of. Okay, element of. Okay, let's recall the symbol that we discussed last time. So this is the symbol element of. Okay, while this symbol is subset of. Okay, so this one we discussed in topic 1 last semester, right? Okay, and yeah, we discussed that natural numbers, subset of whole numbers, okay, and then subset of integers, so on and so forth. Okay, so this is the symbol of subset. But now here we have element of. So, and the Z symbol here, okay, so this represents integer. Okay, so again, what is actually the definition of integer? Okay, so now, do you have any idea what is integer? Integer tu apa?
Integer tu nombor bulat.
Nombor bulat. Ya, yeah, betul. Yes, whole number. Okay, nombor bulat. Which, okay, so correct. Thank you now. Okay, so if your value here is integer, okay, so we will be using this formula. And if the s is not element of integer, so we'll be using this formula. Okay, so now let's see what is basically s. So s is used to determine the location. So to determine the location where the data is located. Okay, so we will be using this formula in order to find s. So you just use n over 100 times k. Okay, so where k is depend on the percentile that we are looking for. So for example, if you are looking for median, so the k here will be 50. Okay, while this symbol, you can see there is a square bracket s. So which means, okay, so this is, okay, the square bracket, and s is basically the least integer greater than s. Okay, so now let's apply the formula. Okay, so when you see the formula, okay, you might think that it's a bit complicated, but actually it is not. So now let's see the application, okay, so that you can see this clearly. Okay, so example 2, find the median for the following sets of data. Okay, so first thing first, okay, before you can find median, okay, you may notice that the data given
Macam ni, benda bilang You. Okay, ini rasanya. Guys, welcome back to the screen.
Welcome to my channel, guys.
Channel. Sekejap, ambil gambar. Okay, ini rasanya. Guys, welcome back to the screen.
Welcome to my channel, guys.
Welcome to my channel, guys. Today we will be streaming.
Ini rasanya. Guys, welcome back to the screen.
Yeah, I am disconnected. Oh my god. Yeah, because the internet is not good here. Oh my god.
Dah buat screen.
Internet is not good here.
Saya pun terkejut bila tiba-tiba dia hilang. Tak tahu nak buat apa.
Yuhan, saya nak leave. Yuhan, jangan leave lagi. Saya dah masuk balik. Okay. Alright. Okay, now let's continue, okay? Without wasting your time. Okay, saya tak nak membazir masa awak because every minute is precious to you. Okay. Alright, okay. So now let's resume. Okay, so I'm going to share the screen now. So for a few minutes, I've been talking to myself only. So this is the challenge, one of the challenges of doing online classes. And this happens everywhere throughout. Okay, not only Malaysia, but the entire world. Okay. So now let's continue. Okay, now I'm gonna... Okay, so... Alright, so where did I stop just now? I mean, you could hear me up until?
Up until you say the formula is seems like complicated but not complicated.
Oh, okay. So, you didn't manage to hear me discussing the A part, example to A.
Bila dah masuk tempat tu hilang.
Oh, okay. Alright. So now let's let's continue. Okay, so now, so again, we are going to use the formula of percentile. So first, when we are provided the data, so we look at the number of data that we have. Okay, so for now, you have 7 data. So we have n equals 7. So we have n equals 7, and you may see that the data we are given in the question are not arranged in order. So first, okay, we just arrange the data in order. And so please make sure, okay, when you answer the question and when you copy down the values, make sure you won't miss any of the data. Yeah? So here the lowest value starts from 17, followed by 20, 21, 24, 28, 32, and 36. Alright, so now because we have n7, okay, we are going to apply the percentile, okay, the percentile formula. But before we find the percentile or the median, the 50th percentile or the median, we are going to find the S first, okay, because why? The S is going to determine the location where the data or where the median is located. Okay, so now because we know median is 50th percentile, so which means in this case the K will be 50. Okay, so 50 over 100 will give you 1 over 2. Okay, so that's why I put here 1 over 2 because we need to find the median, which is the 50th percentile, which is half of the data. So because our n is 7, so here we put 7. So 1 over 2 times 7 is 3.5. Okay, now you see the value here is not an integer. So now once your value is not an integer or your S is not an integer, so we compare with this formula. Okay, the percentile formula you see here, S is not integer, so which means we are going to use the second formula. Okay, so now, okay, and you can see that X, S here, so we can see the square bracket of the S. So this is square bracket of the S, which is the least integer greater than S. Okay, now our S is 3.5. So on a number line, you can see that, okay, if we have S to be 3.5 and the least integer greater than S is 4. So which means here our data is located in the 4th observation. Okay, so again, I repeat, the median is located in the 4th observation. Bermaksud kita punya median terletak di kedudukan yang keempat. Okay, so here after we arrange the data in order, so now you can see that 17 here is in the first position, second observation here, this is the third one, and this our 4th observation. So you can see that here, the 4th observation is 24, so this is basically our median. Okay, so now let's see the B part. Okay, now we have different number of data. So in this case, the number of data is even number. So now you see 1, 2, 3, 4, 5, 6. So we have n equals 6. And again, you may find that the data are not arranged in order. So first thing first, before you start looking for the median, make sure you arrange the data. So by rearranging the data, so this is the sequence that you will be getting. Okay, so by rearranging the data, so this is the sequence, and make sure you list down each and every value without missing any of them. So now we have n equals 6. And now because we are looking for median, so again, it's located in the middle position. So that's why 50 over 100 will give us 1 over 2. And then the n here is 6 because our number of data is 6. So half times 6 will give you 3. Okay, now you see 3 is an element of integer, right? So it falls into the first category. So 3 is element of integer. So we'll be using this formula. Okay, so which means our data, so this is xs plus 1 over 2. So which means our median is located in the third observation. Okay, so which means it's located in the third observation plus the fourth observation. Okay, divided by 2. So now let's identify the third and fourth. So this is the first observation, second observation, this is the third, and this is the fourth. So now you find the sum of this, okay, and then you divide by 2, then you will get 4.92. Okay, so this is basically how to find median. Alright, so are we good so far? Nom and Shamin, are we good?
We good.
Okay, alright.
Madam,
Okay, so yeah,
Madam,
yes,
kenapa
saya.
dia ambil third observation plus fourth observation?
Okay, sebab logically if you see the data here, kita ada 6. Kita ada 6 kan? So nak cari, okay, this is the first, second, third, fourth, fifth and sixth. So kalau nak bahagi 2, bermaksud kalau 6 bahagi 2 dapat 3. So maksudnya data kita kat sini, tengah-tengah ni. Kalau kita bahagi 2 kan, this is the middle value. So actually the median is located in the middle here. So which means it's actually the middle of third and fourth. So that's why we sum the third and fourth and we divide by 2. Dia okay macam ni, okay, based on the first example, the A part, because n is 7. So bila n 7, awak perhatikan so we have 3 data on the left, also 3 data on the right. So this is the middle. Because if n is odd number, then we can straight away figure out the middle value, okay, or the middle data. So kat sini kan sebab because n is odd, okay, nombor ganjil. So bila dia nombor ganjil, so daripada 7 ni kita boleh tahu bahawa observation keempat ni adalah median. So that's why kita dapat 24 as the median. But now because our data here in the B part, the number of data is 6, which is an even number, nombor genap. So kalau nombor genap, kita tengok, okay, di sebelah kiri ada 3 data. Di sebelah kanan pun ada 3 data. So median kita sebenarnya terletak di tengah-tengah ni. Okay, so tengah-tengah ni bermaksud it's actually the mean, okay, the mean of these two value. Okay, the mean of these two. So that's why we sum the third and fourth and we divide by 2. Okay, Syabin? Boleh?
Boleh, Madam.
Boleh Kenapa Syabin nampak freeze di situ? Okay,
Madam,
alright. So,
itu
okay, mungkin Syamil pula now having trouble with internet connection. Okay, so okay, now let's continue. Okay, so the third measure is the mode. Okay, mode ni tak ada masalah because ungrouped data. Okay, so for ungrouped data, mode is set of data or the value that occurs most frequently. Maksudnya yang paling banyak, yang paling kerap keluar ataupun yang paling banyak keluar. Okay, value tu kita dapat yang paling banyak berulang. So that is basically the mode lah. We don't have formula for mode for ungrouped data because okay, we can look at the data at a glance and we can straight away tell the mode value. So you see in this example, find the mode of the following set. Okay, so you see we have 5, 2, 3, 3, 5, 4, 28, 5. Okay, so you can see that the 5 here appears thrice, right? Appear thrice, while the 3 here only appears twice. Okay, yang ni appears twice, while the 5 here okay appears thrice. Okay, so maksudnya dia berulang sebanyak 3 kali. So dari situ kita tahulah mode kita adalah 5. Okay, now you see the B part, okay, each and every data here, they appear only once. Okay, so if each and every data here appears only once, so sekali saja, so tak ada yang paling kerap, so we can say that there is no mode. Okay, we cannot conclude that the mode is everything. Okay, so kita tak boleh kata setiap ni adalah mode. Okay, because they only appear once. Okay, yang mode is basically data that occurs most frequently. So if no value here appears most frequently, so we can just, okay, deduce that there is no mode. Okay, and now for the C part, you can see that there are two values which appear most frequently. So which are, so 0.4 here, you can see 0.4 appears 3 times, and 0.7 here also appears 3 times. So if you have two values which occur most frequently, okay, so we can say that both are actually the mode values. Okay, and okay, so that is one thing. So now we had discussed on how to find the measures, right? So we had discussed on how to find median. Okay, we had discussed on how to find mean and also mode. Okay, so based on these three measures, so these three are called as measures of location. Okay, so based on these three values, okay, so once you get the value, you can actually, okay, determine the okay, the distribution, okay, the skewness of the distribution based on these three measures value. Okay, so you can see the notes here. If the mean value is equal to median and mode value, so we can say that the, okay, distribution is symmetrical. So this is a bell-shaped curve. So this is bell-shaped curve. Okay, bentuk macam loceng. So it is symmetrical about this. So this when the mean is equal to mode is equal to median. Okay, but now here, if you have mode to be the least value, to be the lowest value, okay, what you do is you arrange them first. Okay, so the lowest value will come first, and then followed by the median, okay, and then followed by the mean. Okay, so now how are we going to determine the skewness? Okay, so it's stated here that the data is skewed to the right. Okay, how do we know? Okay, now you just look at the mode, because we know that mode is the data with highest frequency, right? Okay, we can, from the definition of mode itself, we can say that mode is the value which occurs most frequently. So we can say that mode is the data with highest frequency. So in this case, you know that the highest peak will be at mode, and then looking at the two measures here, so it will go to these two measures. So we can say that the data is skewed to the right. Okay, and then here, okay, for the third point, so you see if mean is the smallest value, so first you arrange the data from the smallest to the greatest. Okay, so if the mean is smaller than median, which is smaller than the mode, okay, so how can we tell that it is skewed to the left? Okay, again, you just find where the mode is, because mode is the data which has most frequency, right? Okay, so which means it has the highest frequency, so it will go to the left. So we can say that the data is skewed to the left. Okay, so that is how we determine the skewness of data from these three measures. So again, so this data, these three measures can help us to find the skewness of data. Okay, skewness of data. Alright, okay, so let's say if the question asks you to find the three measures and you need to comment on the distribution. So basically, you can compare the values, identify which one is the lowest and the middle and the highest, and then from there you find the mode and you identify the mode as the highest frequency, okay, the data with highest frequency, and then from there you determine the skewness of the data. Okay, and let's say the quartals. Okay, quartals is derived from the word quarter. It's derived from the word quarter. So, okay, we do have three. Okay, so we do have three types of quartals. Okay, so for example, if I draw this shape, so this is basically first quarter of your data. This is the second quarter of our data, and this is the third quarter. Okay, so we only have three quartals, and what is basically the Okay, the representation of these quartiles. So first quartile is a number such that 25% of the total number data has values less than the Q1. While the second quartile, which is also called median. Why? Because second quartile, you see, if I draw this circle shape and the second quartile is located here. So it's just like you cut the shape into two. So you can say that this is also the medial value, right? So second quartile is also the 50th percentile, which is also the median. So that is how we relate the concept of percentile and quartile. Okay, so it's a number such that 50% or half of the total number of data has values less than second quartile, while the third quartile is a number that 75% of the total number of data has values less than third quartile. So basically we'll be applying the same formula, exactly the same formula. So we are going to use the percentile formula. Okay, how are we going to relate percentile and quartile? So we will be using this. First quartile is basically 25th percentile. Second quartile is basically the 50th percentile, which is also the median. Okay, and third quartile is the 75th percentile. Okay, so again, we'll be using these two formula. So you don't really have to worry. Okay, we don't really have much formula to be used. So basically, we just use exactly the same formula. Okay, so now find the first quartile. Okay, now again, because Q1 is the 25th percentile, so in this case, K will be 25. So if you let K equals 25, then, okay, so K over 100 will give you, okay, 25 over 100, which is exactly 1 over 4, right? So again, the quartile is derived from the word quarter. So quarter is something that you divide into 4, right? Okay, so again, first quartile will give you in the position of 1 over 4 of the observation. While again, when you are looking for second quartile, so when K is 50, so K over 100 will give you, okay, 1 over 2. So it explains lah why second quartile is basically the median, because it's located exactly in the middle of the data, while the third quartile is when the K is 75. Okay, so when K is 75, so your 75 over 100 is basically equal to 3 over 4. Okay, so because first quartile is 1 over 4, so third quartile is just multiplied by 3. So it's located in the 3 over 4th observation. Okay, so now let's find the quartile using the percentile formula. Okay, so now first thing first, make sure your data are arranged in order. So now based on the values that we are given, so they are already arranged in order. So there's nothing much that we need to do. So we just copy down each and every value. Okay, then we just, we identify the number of data we have. Okay, so at the moment we have 1, 2, 3, 4, 5, 6, 7. So now the number of data is 7. We have N7, which is odd number. Okay, so we are going to find the first quartile. Okay, at first we find the location. So S is used to determine the location. Okay, so S here is used to find the location. Kita nak cari kat mana dia berada dulu. So now, so this is to determine the location. Okay, so first, we need to find the first quartile. So 1 over 4 times 7 is 1.75. And you may notice that 1.75 is not an integer, right? So it's not an element of integer. So which means it falls into the second formula. So if it's not an integer, so we are going to get this, where the square bracket S is basically the least integer greater than S. So now because the S is 1.75, so we can say that the least integer greater than 1.75 is 2. So you know that the first quartile is located in the second observation. So it's located in the second observation. So from our data that we have arranged in order, so this is the first observation and this is the second observation. So we can straight away tell that the first quartile is 120. Okay, while now we need to find the median or the second quartile, right? So first, we find the location. So S equals 1 over 2 times 7, which is 3.5. And you may notice that 3.5 is not an element of integer. So again, we'll be using the second formula. So, the round bracket of S, sorry, not round bracket, the square bracket of S tells that okay, is basically the least integer greater than s. So now since our s is 3.5, so the least integer greater than 3.5 is 4. So our data is located in the fourth observation. Okay, so you can see that. Okay, so this is third observation. So this is the fourth observation. So this is basically our median or second quartile. Okay, then finding third quartile. So first we locate where it is. Okay, so we put 3 over 4 times 7. Again, we get a value which is not an integer. Okay, which is not an integer. So again, we'll be using the second formula. And you see the least integer greater than 5.25 is 6. Okay, so the least integer greater than 5.25 is 6. So which means our data is located in the sixth observation. Okay, so now you see this is our fifth observation. So this is the sixth observation. So basically 148 is the third quartile. Okay, so this is when the n is odd. Okay, now let's see second example where the n is even number. Okay, so here we have this data. Okay, and if you count all of this, so you will notice that n is equal to 12. Okay, which is an even number, right? Okay, and you may find that the data here are not arranged in order. So now we are going to rearrange them. Okay, so by rearranging the data in order, so you will find that, okay, it will be in this sequence lah. And again, whenever you list down the values, make sure you don't miss out any of them. Okay, so now we arrange from the lowest until the highest. So the lowest is 23 until the highest is 52. Okay, now we are going to locate, okay, so by using the value of S. So in order to find the location of first quartile, so we put 1 over 4 times 12. Okay, and now you see we are going to get the value of S to be 3, which is an integer. So when it is an integer, so it falls into the first category here, into the first formula. So which means our data is located in the middle of third and fourth. So the formula here will be, okay, because S is 3, right, in this case. So S is 3, so, and S plus 1 is 4. So which means our data is located in the middle of third and fourth observation. Okay, so after you arrange the data in order, so you can see that this is first data, second observation, third observation, and the fourth observation. So how to get the first quartile? You just sum 34 and 35 and you divide by 2. So that's why you get 34.5 as the answer. Alright, okay, then how to find the second quartile? Again, because it's located in the middle, so you have half times 12. And you notice that the S value is an integer. So again, if it's an integer, it falls into the first formula. Okay, so because S is 6, okay, so first it is an integer, so it falls into the first formula. And because S is 6, so here we have 6 and S plus 1 will give you 7. So basically, our data is in the middle of 6th observation and 7th observation. So, okay, by identifying the observation, so you see this is the 5th observation, 6th observation and 7th observation. So ini adalah sebutan yang ke-6 dan sebutan yang ke-7. Okay, so we just total up these two and we divide by 2, so that will give us 41. Okay, and then lastly, finding the third quartile, we find where the location is. So we find 3 over 4 times 12, which is 9. And again, it is an integer. So, okay, it falls into the first type of formula. Okay, so in this case, the S is 9. Okay, so it falls into the first formula here and the S is 9 here. So we know that the data is located in the middle of 9th and 10th observation. So here, this is the 8th observation, 9th observation, and this is the 10th observation. So ini adalah sebutan ke-9 tambah sebutan ke-10 bahagi 2. So 44 plus 46 divided by 2 will give you 45. Alright, so now are we good so far? Okay. Are we good, guys?
Yes, madam.
Yes,
Yeah.
alright. Yeah, okay. Iza, is it also? Yes.
Madam.
Okay. Yeah.
Kalau contoh macam kita skip S punya, maksudnya kita skip jalan kerja S tu, so maksudnya macam kita, kalau kita kira kan ada 7 nombor N tu ada
Okay,
7.
7 nombor.
Kita ambil tengah-tengah je terus. Tak cari
Tengah-tengah
S.
maksudnya awak tahulah 7 bagi 2 tu, terus awak dah tahu tengah-tengah tu 3.5 macam tu. Okay, okay, yang itu biasa tak ada masalah lah. Contoh kalau awak tahu bahawa 7 bagi 2 sama dengan 3.5, so awak terus conclude bahawa your median is your fourth observation. So you just write down X4 lah.
So maksudnya yang cari S ni ada markah ke tak?
Biasanya dia boleh embedkan dekat contoh dia boleh embedkan dekat sini. Okay, let's see dia boleh embedkan dekat sini lah, macam contohnya awak nak cari median. Okay, so 7 divided by 2 is 3.5 kan, so dia boleh embedkan kat sini. So once you write down your median is located in the fourth observation, so basically the 4 ni kita tahulah when the S is 3.5 and terus awak buat 4, contoh awak tak tunjuk atas, okay, contoh awak skip tapi awak tulis kat sini X4, so kita boleh bagi K1 kat sini. Okay, boleh?
Okay,
So
madam.
kalau boleh at least tulis X4 lah, janganlah terus lompat Q2 sama dengan 138. So nanti examiner tak tahu macam mana awak obtain 138 tu. Okay?
Boleh.
Okay. And also okay, usually the question won't simply ask you to find median only. Okay, biasanya soalan akan minta quartile, percentile. So maksudnya kena tunjuk jalan kerja dengan jelas lah. Sebab kalau median, okay, tak ada masalah, kita boleh tengok terus tengah-tengah. But when it comes to quartile ke percentile, so macam ni kita nak tengok kan. So nak tak nak memang kita kena cari S tu. And again, when it involves big data, for example when N is 20, let's say. So macam ni kita nak tahu the 70th percentile. Okay, where is it located? So again, the good way or the best is you need to show the S lah, how you find the S. Okay? Alright, okay, so now let's continue. Okay, how are we going to draw box and whisker? So coming to the second objective for today. Okay, box and whisker. The literal meaning, box is what? So box is simply box lah. Okay, whisker ni apa? Whisker ni misai kan? So misai, adakah misai kucing tu? Ataupun misai manusia? Misai Nok ke misai Syamin? Okay, so this is basically the shape of box and whisker lah. So this is basically the box and this is the whisker. Okay, so this is how it looks like. Okay, so again, what is box and whisker? So it gives a graphical description of data using 5 measures, namely median, first quartile, third quartile, smallest and largest values in the data set. Okay, so what can we tell about the box and whisker? It shows the center, the spread and skewness of a set of data. So we can tell the skewness of data and how the data spreads based on the box and whisker plot. Okay, so again, in order to find your box and whisker plot, okay, so you need to have the measures here. So you need to find the first quartile, the second quartile and the upper quartile. Okay, and not only that, you need to have your fence. There is. So this is what we call as lower fence. And this is upper fence. Okay, so and I just need you to add on. If you already have your summary. Okay, so if you already have your summary of topic 6, so I need you to add this. Okay, so here you add this lower fence. Because the fence also have to be shown, the fence, lower fence, and this is upper fence. So the meaning of fence is what? The translation of fence is pagar kan? Okay, so this is basically the fence. Okay, but we do have formula for this. So the lower fence, okay, so we will have formulas. The formula is Q1 minus 1.5 times IQR. Okay, you copy down this one first, and then the upper fence, the formula is Q3 plus 1.5 times IQR. Okay, why this one, the lower fence formula is minus and the upper fence here is plus? Because actually the arrangement of the values here, they are arranged in order. Okay, they are arranged in order, in ascending order. So we know that Q1, the value is going to be less than Q2 and less than Q3. And because the upper fence here is located on the right of Q3, so that's why the formula here is plus, because the upper fence value is going to be greater than the Q3. While here, you can see that the lower fence here is located on the left of Q1. So we know that the Q1 value is going to be greater than lower fence value. So that's why the formula here is Q1 minus 1.5 times IQR. Okay, what is IQR? That is interquartile range. Okay, so now let's discuss, okay, the methods on how to find the box and whisker plot now. Okay, so, okay, how can we tell the shape of the distribution? Okay, just now we can tell the skewness of data from the values of mean, mode, median, right? So again, okay, mode, median. Okay, so if your mean is smaller than the median and then smaller than the mode, okay, so we know that the mode has the highest frequency, so it's skewed to the left. Okay, so skewed to the left. Okay, now if the mode is the lowest value, okay, which is less than median, which is less than mean, so we know that the mode takes the highest frequency and it will be skewed to the right. Okay, and not only that, we can also tell the shape of the distribution or the skewness based on the quartiles values as well. Okay, so how can we tell? Okay, so you can have symmetrical distribution if the measurement of the boxes here are equal. For example, here you can see the distance between Q1 and Q2 is equal to the distance between Q2 and Q3. So they are equal distance. So we can say that this symmetry, okay, the distribution is symmetry. Okay, but then how can we have positively skewed distribution if the median is nearer to the Q1? So you can see here, okay, the box here is smaller than the box here. The box on the left is smaller than the box on the right. So you can see that the data is skewed to the right. Okay, so if I take out the boxes, so here, if the box on the left is smaller than the box on the right, okay, so you can tell that the data is skewed to the right. While the opposite way, if the box is smaller on the right, okay, so you have the data skewed to the left. Okay, so that is how we determine the skewness based on these measures, yeah, the quartiles measure. Okay, so now, alright, so okay, to construct a box plot, so first thing first, you need to find the measures here, the quartiles, first, third, and third quartiles, and we find the interquartile range. Okay, so what is the formula of interquartile range? So it's basically Q3 minus Q1. Okay, so that's why you need to obtain Q1, Q2, Q3 first. Then you can find the interquartile range from the Q3 and Q1. Okay, so again, interquartile range is Q3 minus Q1. And then step 2, we find the fences. Okay, so again, these are the two formula that I introduced just now. So the lower fence formula is Q1 minus 1.5 times IQR. And the upper fence is Q3 plus 1.5 times IQR. Okay, and then step 3, determine the smallest and largest values within the two fences. Okay, so the smallest and largest here, they don't require any calculation. You can simply observe the data that we are given. So here you can observe the data here. You identify the smallest and largest values, okay, within the two fences. And then step 4, we draw horizontal line and mark the levels, yeah. So check if there are values fall outside the fences. Okay, so any values fall outside the fences are called as outliers. Okay, so now let's see an example. And this example also, okay, been provided together with the solution, yeah. Okay, so I hope that you can just have a look at the solution. So how can we find the box and whisker? How can we draw? Okay, first, again, okay, in order to determine the quartiles, we need to rearrange. Yeah? So make sure that the data given are in order, okay, in ascending order. Okay, so now we arrange, starting from the smallest value. Okay, so this is the smallest data. Okay, we rearrange up to the largest one lah. Okay, now, okay, and you identify the number of data that we have. So if you calculate them all, so you will notice that n is equal to 15. Okay, now let's identify the locations of the quartiles. So we are going to use the formula of S. Okay, so first quartile is located in the 1/4 observation times the n. So you can see here the S value is 3.75, which is not an integer. So again, if your data is not, okay, if your S is not an integer, so which means the first quartile is located in the fourth observation. Why? Because we take the least integer greater than 3.75. So the least integer greater than 3.75 is 4. So we know that the first quartile is located in the fourth observation. Okay, in the fourth observation. So from our data here, you see this is the first observation, second observation, third observation, and this is the fourth one. Okay, so the fourth one here, so we know that the first quartile is 550. And we are talking about what? We are talking about the salaries for a sample of 15 households. Okay, so now let's find the second quartile. So we find the S first. Okay, so S is half times 15, and you see the value is 7.5, which is also not a subset of, an element of integer. So if it's not an element of integer, so we just take the least, okay, integer greater than 7.5. So you see this is 8. So which means our second quartile is located in the 8th observation. Terletak di kedudukan yang ke-8. So now kat mana kedudukan ke-8? Okay, so now you see this is the 5th, the 6th, the 7th, and this is the 8th one. So now we can say that the second quartile is 750. Okay, now how to identify the location of the third quartile? Okay, so we use S as well. So 3/4 times 15, 11.25. Again, not an integer. So we take the least integer greater than 11.25, which is 12. So now our data is located in the 12th observation. Okay, so di manakah 12th observation? So here we calculate, okay, we find it. So this is the 9th, this is the 10th observation, this is the 11th observation. So this is the 12th. Okay, so now we know that the third quartile is 900. Okay, we have got all the measures. Okay, so first, second, and third quartiles are done. Okay, now let's find the values of the fences. Okay, we begin with the lower fence. So the formula is Q1 minus 1.5 times interquartile range, right? And we know interquartile range is Q3 minus Q1. Okay, so we substitute the values here. So Q1 is 550 minus, okay, 1.5 times Q3 900 minus Q1 550. And you see the value of the lower fence is 25. And now we find the upper fence value. So the upper fence formula is Q3 plus 1.5 times interquartile range. So interquartile range is Q3 minus Q1. Okay, and we substitute the value. So the value of Q3 is 900, and then plus 1.5 times Q3 minus Q1, and we get the upper fence value to be 1,425. Okay, so after we have got the fences, then we just, okay, we label them. Okay, and your box and whisker, they don't really have to be up to scale, but okay, it's just that you just need to make sure when you draw the boxes, okay, if there is a difference between the sizes of the boxes, then you please show it. Okay, so in this case, you can see that the Q1 here is 550. So this is the value of Q2, and this is the value of Q3, right? Okay, if you press calculator and you find the difference, so this is 150. The difference here is 200. So you can say that, okay, 200 is greater than 150, right? So when you draw the box, okay, so you just need to show that the first box is greater than the second box lah. Okay, they don't really have to be up to scale. Maksudnya tak payahlah guna pembaris tengok dekat sentimeter tu betul tak measurement dia, jarak dia. Okay, but you only need to show that the first box is greater than the second box. Okay, And then when it comes to the whiskers, okay, because now how do we identify the whisker? Okay, let's look at the data here. Okay, the smallest value is 420, and because it's still greater than the fence, so which means the 420 is located here. And here the largest value is 1200, so it's located before the upper fence. Okay, so and how to determine the whisker? Okay, so you just need to show that, okay, in this case, you see the difference between this Q1 and the lowest value is smaller than the difference between, okay, 1200 and the Q3. Okay, you see the distance here is 300, while the distance here is only 130, right? Okay, so you just need to show that the whisker on the right is longer than the whisker on the left here. Okay, so that's it. Okay, again, you don't really have to draw it up to scale, but you just need to show clearly which whisker is longer than the other, and also you need to show which box is greater than the other. Okay, and then you need to show also clearly the fences, yeah. So in this case, the lower fence is 25. Okay, and the upper fence here is 1425. Okay, so this is basically how we sketch our box and whisker plot. Okay, alright, so now a second example. Okay, so following data shows summary of the marks for mathematics and biology for students in the class. Draw 2 box plots for this data and give comments. Okay, so now you can see the answers are given straight away. Okay, so and comments regarding the distribution. Okay, so you can see clearly the median marks for both subjects are the same, but the marks for mathematics show bigger range and it's skewed to the left. Okay, so you see here it's skewed to the left for the maths. Okay, the biology marks have smaller range compared to the mathematics, and the distribution of marks biology is almost symmetry. Okay, why almost symmetry? Because, okay, you can see that the value basically here, the difference here is, okay, the distance between first quartile and the second quartile is 12, and here the distance between, okay, so 24. It's actually double than this. Okay, and I would say it's not really almost symmetry. It's also more, okay, because here the distance is 15. And I would say the one which is, sorry, this is not 15, this is 25. Okay, so we can say that the box here, the box on the right is smaller than the box on the left. This one also, the box on the right, smaller than the box on the left. So we can say that, okay, why is it almost symmetry? Okay, because of the whisker. Okay, so we can say that the whisker here, okay, tells the symmetrical shape of the data. Okay, while the mathematics here, we can see here the, okay, it has the bigger range because why? You can see the minimum mark is 10 and the highest mark is 90. So it tells you the bigger range. Okay, how to find range? So basically the lowest, okay, the highest value minus lowest, highest minus lowest. Okay, and then, okay, we can use box plots to identify outliers. Yeah? So again, what is outlier? So outlier means it's an extreme data. Extreme data means, okay, I give example ya. Contoh UPS 1. Okay, semua orang dapat A 80 sampai 100 and tiba-tiba ada seorang dapat markah 30. So we can say that that is outlier. Okay, the extreme value which is outside of the rest of the data lah. Okay, maksudnya kawan-kawan yang lain semua dapat range yang lebih kurang sama tapi dia seseorang tiba-tiba dia fail. So that is outlier. Or towards one extreme, okay, contoh yang satu kelas tu 18 orang gagal, tiba-tiba seorang dapat 100. So that is also outlier. So outlier, it can be in both extents. It can be either the extreme mark in the sense of it's the lowest, or okay, it can be towards one extent. Okay, it can be outlier in the sense that it is the highest. Okay, so now let's see. Okay, now if you have the lower fence and you have the upper fence, okay, I need to remind you, the whisker, they cannot cross the fence. Okay, so I use red pen here. So whisker, you have to make sure that the whiskers cannot cross the fence. Okay, which means, let's say, if your smallest value is located outside the fence, so that means here, okay, this is the smallest lah. Okay, after we arrange the data in order, okay, let's say your data here, the smallest value is outside the fence. Okay, so then how are we going to draw the whisker? So for this value, you are going to get the second smallest value. Okay, why? Because the smallest is already outside the fence. So in order to draw the whisker, we take the second smallest value. Okay, now let's see an example. Okay, so the following stamp plot shows the maximum temperature for each day from 1st August to 23rd August in a town. So draw a box plot and use the box plot to identify the outliers. Okay, so now I would say we are talking about the temperature in Fahrenheit. Okay, because they are in 50s and 70s, right? And I think, yeah, the key is missing. Okay, as what we discussed yesterday, when you need to draw your stamp and leaf plot, make sure you provide key, right? Okay, so in this question, so the key here, 51 means 51. Okay, so now, when you calculate the number of data, so you will notice that the number of data is 23. So if you calculate the number of leaves that we have here, okay, you can find that the number of data is 23. Okay, so now let's find all the measures, the quartiles, first, third, second, and third. So because the n is 23, so we find the location first as 1/4 times 23, 5.75, which is not an integer. So our first quartile is located in the 6th observation. So how can we identify the 6th observation? So you see, this is the first. Okay, this is the first, second, third, fourth, fifth, and so this is our 6th observation. So we can say that, okay, the data is 64. So the first quartile is 64. Okay, now we find the location of the median or the second quartile. So it's half times 23. So we get 11.5, which is also not an integer. So we round up the value. Okay, we round up the value. So it's 12. So our data is located in the 12th observation. So we find it. So this is 7th, 8th, 9th, 10th, 11th, and this is the 12th observation. So you can say that the median is 67. And okay, we can find the third quartile. So it's 3/4 times 23, so which is 17.25. So which is not an element of integer, so we round up the value. Okay, so the least integer greater than 17.25 is 18. So which means our data is located in the 18th observation. So the third quartile, okay, so you just find here. So this is the 12th, 13th, 14th, 15th, 16th, and 17th, 18th. So this is the 18th observation. So we can say that the third quartile is 70. Okay, so now let's find the lower fence. Okay, so we find the lower fence from the formula just now. It's Q1 minus 1.5 times interquartile range. Okay, so this is the answer. And next we find the upper fence. So this is third quartile plus 1.5 times interquartile range, okay, which is Q3 minus Q1. So this is the answer. Okay, now after we have got the fences, okay, so okay, first you may plot the box, all right? So this is your Q1, Q2, and Q3. And you see, in terms of distance, here the difference is 3. And here also the difference is 3. Okay, so now when you draw the boxes, make sure you draw them, okay, in equal sizes. All right, because the difference, okay, the differences here are equal, right? The differences here are equal, 3 and 3. So which means you can say that the boxes are of equal sizes. Okay, now what you do, okay, you draw the fence second. Okay, first you draw the box. You draw the box. Second, you draw the fence. Why? Okay, why don't we put the values here, the whisker? Because, okay, the fence, okay, the fences here, the lower fence and the upper fence here will determine, okay, the whisker. So now, okay, we get the fence value, the lower fence 55, right? Okay, so now we label the 55. And then the upper fence is 79. Okay, so then we label the upper fence 79. Okay, now let's go back to our data. Okay, you see here the smallest value. So this is the smallest value, right? 51. So this is the smallest value that we have. And this is the highest value that we have. Okay, 77 is the highest or the largest data. Okay, so 77 is the highest. Okay, and you will see that 77 is highest and it is smaller than 79, right? So which means your highest data is in the fence. Okay, but when it comes to the smallest data, so you see the smallest data is 51. So 51 is outside the fence. Outside the fence. Because why? Because it's smaller than the 55. 51 is smaller than 55. So how are we going to get the whisker on the left? So in this case, we take the second smallest. Yeah? So this is second smallest data. Second smallest data. So we take the 59 because now 59 is greater than 55, right? So here that's why we take the second smallest data and just we draw the whisker. And here also we draw the whisker. And because the difference here is 5 and the difference here is 7, so you just need to show that the whisker on the right will be longer than the whisker on the left. Okay? Alright, are we good so far? Are you able to follow?
Yes, madam.
Yes, huh?
Boleh.
Boleh. Okay. Yes. Sam, everything is clear for me. Okay, Sam, good to know that. So far, so good. Alright. Okay. Oh, kita ada pelajar daripada sekolah. Cuba tengok. Kita ada pelajar daripada sekolah. Sekolah Menengah Kebahasaan Sultan Mansur Shah. Okay. Alright, Ain Musa, good, madam. Alright, Abby, we have. Okay, yes, madam. Okay. So, good to know that. Okay, so actually topic 6 is the easiest one. Okay, so it's all about calculating the measures using formula. Okay, so the formula also will be provided in UPS and also in assignments, so you don't really have to worry. Okay, you just need to use the formula correctly. Okay, so now, okay, we are done with the second learning outcome. Okay, so coming to the last one for today. So the last learning outcome for today is to find the measures, okay, which are the mean, mode, median for group data. Okay, again, what's the difference between group and ungroup? Okay, so it's just with the interval. If you do have the intervals, then you can say that, so the data is group data. Okay, so now how can we find the measures here? Mean, mode, median for group data. Okay, so the formula of mean. Okay, so we have this formula, yeah? So it's also represented by x bar. So the formula is sum of fx divided by sum of f. Okay, and then mode. All right, so for mode, okay, mode for ungrouped data, we don't have formula just now, right? We just look at the data which appears most frequently. But now when it comes to group data, we do have formula. Yeah? So mode, okay, so mode is, okay, the formula of mode is this. It's LM. So what is LM? It's the lower class boundary of the mode class. Okay, and then D1. What is D1? So it's the difference between the mode class frequency and the previous class. Okay, then D2 is the difference between, okay, so this is D2, the difference between mode class frequency and the class after. And then what is the small letter c? Small letter c is the class width. Alright. Okay, let's go through all the formula first. Then we come to one example discussing all of these measures. Okay, again, median, we can calculate the median by using percentile formula. Okay, so, okay, what is percentile formula? Now let's see here. We have LK, which is lower class boundary of the median class. Okay, and then N is the number of data or the sum of frequency. And then the capital F is the okay, you see capital F, K minus 1, right? So it's actually cumulative frequency before the median class. So C is the class width. The small letter F is frequency of median class. Okay, and then when we find, okay, when we need to find the quartiles, so we don't really have to worry because we are going to apply this formula as well. So, okay, we can find the quartile by finding the 25th percentile. We can find second quartile or the median by finding the 50th percentile. And Q3, okay, the third quartile can be obtained by finding the 75th percentile. Okay, so now you see the K here will depend, okay, on the measure that we are looking for lah. So let's say if you are looking for first quartile, which is 25th percentile, so in this case the K value is going to be 25 lah. Okay, and here is 25 lah, so that's why Okay, 25 over 100 will give you 1 over 4. Okay, so that is how we obtain the first quartile. Okay, now let's jump to the example. Okay, so I give one example only and we can find all the measures from this. Okay, so now for the frequency distribution below, okay, so we are required to find all of these measures. All of these measures. Okay, so now let's see how to find them. Okay, and yeah, once you come across this kind of question, the idea is, okay, you need to identify whether you are given interval or boundary. So in this case, we are given class interval. Okay, what's the difference between class interval and class boundary? So the interval, okay, the interval is given when the upper interval here is not equal to the lower one here. Okay, so you see there is no, okay, the values are not equal, right? So, okay, once you can see the values are not equal, so you can say that this is class interval. Okay, once you are given class interval, so you need to transform this into class boundary. Why? Because, okay, in order to find median, okay, you can see that the one of the formula here is LK. LK is what? It's lower class boundary. So you need to obtain your class boundary before you can find those measures. Yeah. So the same thing applied for mode also. Okay, the LM here stands for lower class boundary. So the keyword here is class boundary. Yeah. So okay, now once you are given class interval, so you need to express in the class boundary, okay, before you can find the measures. So how to do this? Okay, so this is the table that we're going to have. Okay, so this is the class interval. Again, what's the difference between interval and boundary? So you see in terms of values here, so they are not equal. So this is 29 and this is 30. So they are not equal, right? Okay, so how can we get class boundary? So what you do is you just add these two, 29 plus 30 divided by 2. So you will get 29.5, 29.5. And then here, 39 plus 40 divided by 2. So you will get 39.5 here and 39.5 here. And then here, 49 plus 50 divided by 2. So 49.5, 49.5. And then here, so on and so forth. So you will have 59.5. Then here, 69 plus 70 divided by 2. This one, 79 plus 80 divided by 2. Okay, and then because, okay, how are we going to write in this? Okay, because for this one, we don't have previous class, right? And this one also, we don't have class after. So you just look at the class width. The class width is calculated by, okay, subtracting the upper boundary. So this is upper boundary with the lower boundary here. Okay, so you just subtract 39.5 minus 29.5 is 10, right? So you can obtain your lower boundary here is by subtracting 29.5 by 10. So you will obtain 19.5. And then here, 79.5 plus 10 will give you 89.5. Okay, so that is how we obtain the class boundaries. Okay, now the frequencies are given based on the question. So it's just a matter of copying them back. So we just copy all the frequencies down. Okay, and we notice that the sum is 120. Why the sum is 120? Because that is the data given. Okay, and then, okay, we look, okay, we find the cumulative frequency. So the cumulative frequency is the accumulation of the frequencies. How can we find it? Okay, so first, okay, for the first class, here we just write down the cumulative frequency 4. And then for the next one, we just add with 11. So 4 plus 11 is 15. And then 15 plus 20, it's 35. And then 35 plus 45, 80. 80 plus 25, 105. 105 plus 12, 117. Then 117 plus 3 is 120. And again, how to make sure that your cumulative, how to check whether your cumulative frequency is correct. So the value here must tally with this sum of frequencies value. Okay, so now, okay, the last value of cumulative frequency is 120. So this is also equal to the sum of the frequencies. So that means we are on the right track. Okay, and then now how to find the x? So in order to find the x, because we are given the data in class form, right? Okay, so how can we determine the x? So we are going to find the middle values. Okay, so here we just add these two, 19.5 plus 29.5 divided by 2. Okay, so you will have the values, okay, the value here 24.5, and you do so on and so forth for the rest of the classes. So you will have all of these middle values. Okay, now the purpose of finding fx, which is actually the product between frequency and the x. Here, frequency with the x, frequency with the x, so that it will help us to find the mean later. Okay, so rather than you do, okay, now how to find the mean? So rather than what you do is, okay, you write this down, 4 times 24.5 plus 11 times 34.5 plus 20 times 44.5, so on and so forth. Okay, so rather than writing this down, okay, in such a long sentence here, okay, such a long math sentence here. So what you can do is, okay, you can do them here in the table. So you just find the sum and you substitute into the formula. Okay, so the sum of fx is 6580. Okay, first you just multiply the frequency with the x, and then you just find the sum all of these values. Okay, and then you transfer the value here. So the sum of fx is 6580, and then divided by sum of f, which is here 120. So you will obtain the mean to be 54.8. Okay, 54.8. And now mode. Okay, so mode, how to find the mode? Okay, first we are going to identify the class, okay, the mode class. How are we going to identify the mode class? Okay, so you look at the table. Okay, so how can you identify the mode class? We find the class with highest frequency, because again, okay, for ungrouped data, we find the data which appears most frequently, right? So from there we know that mode is basically any data which has the highest frequency. So in this case also, so you see this is the frequency column, right? So out of these values, so you can find the highest frequency, which is 45. So in this case, we can say that this is basically our mode class. Okay, so the mode class here is 49.5 until 59.5. Okay, so now, okay, let's recall the formula. So LM, what is LM? It's basically the lower boundary of the mode class. Again, we always refer the class boundary, yeah. So okay, but okay, in order to find the measures, okay, the class interval can be ignored. I mean, we won't look at the class interval anymore. We only refer the class boundary, yeah. Okay, so the mode here you can find by finding the lower boundary. So after we have identified the mode class, so we take the lower boundary here, which is 49.5. Okay, then plus with, okay, D1. What is D1? So D1 is the difference of frequency of mode class and the class before. So you see the class before, the frequency is 20, right? So 45 minus 20 is 25. So that is the value of D1. And here also you write down 25. And then what is D2? So the D2 is the difference between the mode class frequency and the class after. So D2 is the difference in the class after. So this is D1 and this is D2. So 45 minus 25 will give you 20, right? So we put 20. And then what about class width? So class width is the upper boundary minus the lower boundary. So it's 10. Again, I need to remind you, in order to find class width, please use class boundary. Because most common mistake done by students, they simply find the class width from the class interval. If you use class interval, then 29 minus 20 will give you 9. So in this case, C equals 9 is wrong. The class width is not 9. The class width here is 10. Why? Because we need to use the class boundary, not the class interval. So again, you can just ignore the class interval here. So we'll be, okay, focusing on the class boundary to find the class width. Okay, and not only that, also we use class boundary to identify the lower boundary here. Okay, so we just press calculator. So this is the value of the mode, 55.06. Okay, now how to find median? Okay, we are going to identify the location first. Okay, now we'll be using the percentile formula, right? So this is the percentile formula. Okay, while in this case, the K will be 50. Why? Because we are looking for the median. So which means it's located in the, okay, 50th location. Alright, so how can we identify? So now because the N or the sum of F is 120, so we divide by 2. Why by 2? Because median, right? So median is located in the middle. So we divide by 2. So it's located in the 60th position. Okay, so how to identify the position? Okay, from the cumulative frequency, okay, we look at the cumulative frequency. You find where the 60 is located. You see, okay, this is 4, so not less than 60, 15 less than 60, 35 less than 60. Okay, now we know that 60 is located here. Okay, because it's greater than 35 and less than 80. So the 60th observation is located here. And from there, we can conclude that this is also not only mode class, this is also median class. Why? Because again, 60 is located here. Okay, and then, okay, again, by using the formula, so we will be, okay, the formula, so the lower boundary is 49.5. Okay, from here, 49.5. And then plus with, so K over 100. Okay, now because we are looking for median, so the K here is 50. So it's 1 over 2 times 120. And okay, this is cumulative frequency of the class before. So okay, because we identify this to be the mode class and also the median class, so we minus with the cumulative frequency of the class before, which is 35. Okay, and then divided by frequency of the median class. So you see, the frequency of the median class here is 45. And then again, multiply by class width, which is 10. And then you will get the median value. Okay, so now we have got the 3 measures. Okay, now let's say I add on one question. Okay, identify the skewness of the data based on these 3 measures. You have got the mean, you have got the mode, and the median. How can you identify the skewness? Okay, now let's compare the values. Mean is 54.8, mode is 55.06, and median also 55.06. So you can say that the median is the lowest, right? So in this case, sorry, the mean is the lowest. So mean is smaller than mode, which is equal to the median, right? In this case, the values are equal. Okay, so how can we identify the skewness? Okay, again, identify the mode which has the highest frequency, right? So the highest peak will be at mode and then going to the left, because the mean is located on the left. So we can say that the data is skewed to the left. Okay, just in case if you are required to identify the skewness of the data. Okay, now how to find quartile? So we'll be using the percentile formula as well. So again, you locate where it is located. Okay, you locate the observation. So in order to find the first quartile, it's 1 over 4 times 120. So which means, okay, it is located in the 30th observation. Okay, 30th observation means if you look at the cumulative frequency, okay, so if you look at the cumulative frequency, so 30 is located here, right? 30 is located here. So we know that this is the first quartile class, Q1 class. Okay, and we know that the lower boundary is the Q1 is 39.5. So here we have 39.5 plus 1 over 4 times n 120 minus, okay, the cumulative frequency of the class before. So you see the cumulative frequency of the class before is 15 and the frequency of the Q1 class is 20. So minus 15 divided by 20 times the class width 10. So this is your Q1. Okay, 47. And here also the Q3. Okay, how are we going to identify? So it's, okay, 3 over 4 times 120. So it's located in the 90th observation. So 90th observation means from your cumulative frequency, where is 90 located? So it's located here. Because it's greater than 80 and it's smaller than 105. So we know that this is Q3 class. So this is Q3 class. Okay, so we know that the lower boundary of Q3 is 59.5. Okay, so you see the lower boundary is 59.5 plus with 3 over 4 times n minus cumulative frequency of the class before divided by frequency of the class and then times with class width. So 63.5. Okay, by comparing the value, so you see Q1 is 47, Q2 or the median is equal to 55.06. Okay, and then Q3 is 63.5. Okay, now you see in terms of distance, which one is greater than the other? So the distance here, it's 47 until 55.06 is about, okay, is about 8.06, and here the distance is about 12 point something. Okay, 12.24. Okay, so you can see if you draw the box. Okay, so if you draw the box of Q1 minus Q2, here will be smaller than the Q2, okay, the Q3 minus Q2. Okay, and then, alright, so we can find the interquartile range by subtracting Q3 with Q1. So we have 16.5, and then percentile, yeah, so this one, okay. So the G part, okay, we need to find, let's look at the question, 10th percentile. So in this case, we locate the position. So 10 over 100 times 120. So we identify the location. So 10 over 100 times 120. So it's located in the 12th observation. So if it's located in the 12th observation, so from the cumulative frequency, okay, so you see from the cumulative frequency, where is 12 located? So 12 is located here. Okay, so 12 is located here. So we know that this is the class of 10th percentile. Okay, so we know that the lower boundary is 29.5. So we can substitute into the formula. Okay, 29.5 plus, okay, 10 over 100 times the sum of frequencies minus, okay, the cumulative frequency of the class before, and then divided by frequency of the class, okay, then times with class width, you get this. Okay, now for the last one, okay, what is H? So let's, okay, find the value of M is 30% of the data is greater than M. So what does it mean actually? Okay, if you draw just a straight line here, okay, find the value of M. So it's given here, find the value of M if 30% of the data is greater than M. If 30% of the data is greater than M, so we know that there is 70% of the data which is smaller than M, right? Okay, so in this case, we can conclude that if there are 70% of the data less than M, so we can conclude that M is actually 70th percentile. Okay, so that is how we identify, okay, what the question is all about. Okay, so find the value of M. So again, if I draw like this, okay, if I draw like this one, okay, find the value of M such that 30% of the data is greater than M. So we know from here also, okay, 70% of the data will be smaller than M. So in this case, we can conclude that M is 70th percentile. Okay, so how can we obtain the 70th percentile? So 70 times 100, sorry, 70 divided by 100 times 120. Okay, so from there, you can obtain the location. Okay, so it will be located in the 84th location, 84th observation. So from here, you can say that 84 is located here. So this is not only the class for Q3, this is also class for 70th percentile. Okay, so the lower boundary is 59.5. Okay, so from there you can just obtain, you can just obtain the lower boundary, which is 59.5 plus with 70 over 100 times the n minus with the cumulative frequency of the class before divided by frequency of the class times with class width. And this is the value that you will be getting. Okay. Are we alright?
Boleh.
Boleh ya? So, senang ke susah? What do you think, Syamil? Now,
Agak boleh juga lah.
Yang dia bila dah sampai percentile yang group data tu dia macam payah sikit.
Nah, dah mula petak.
oh, okay, tapi I think the sama juga kaedah dia adalah mencari dulu lokasinya di mana. Sama juga dengan ungroup tadi kan kita cari S dulu. So untuk group pun sama, kita masih lagi cari locationnya di mana, then baru kita determine the class. Kenapa ada?
So saya tengah fikir macam mana saya nak conteng nanti saya punya data dalam jadual tu. Macam mesti serabut.
Dalam jadual ya, you need the table ya. Okay, Mr. Ain cakap senang tapi banyak kena nak kena memorize. Sekejap, siapa yang... Okay, the thing is, okay, I don't think that you need to memorize because the formula will be provided, yeah, and because the topic here, okay, will be covered in PSPM. Okay, so now let's see, okay, the summary. From the summary here, you can see that, so this is the formula. Okay, so last time, for previous, okay, years, this formula being provided in exam. Okay, but now because this topic is no longer covered in PSPM, so in UPS later, we will provide you also with this formula. So you don't really have to worry lah. Okay, so it's just about how to apply this formula. So let's recall. So the formula of mean for group data is sum of fx divided by sum of f. For ungrouped data is sum of x divided by n. Then the mode is, okay, the lower boundary of the modal class or the mode class plus with the difference of the frequency of the mode class with class before. And this one also, and D2 is the difference of the frequency in the mode class and class after. And then for ungrouped data, how to find the mode? We just choose the data which appears the most or the data with highest frequency. And then when it comes to percentile, okay, so this is the formula for group data and this is formula for ungrouped data. First, you find the S, okay, and you identify whether the S is integer or not. Okay, but when it comes to group data, okay, before you start using this formula also, you need to locate where the data is lah. So again, you just use the K over 100 times the sum of F lah. Okay, let's say, okay, just based on our previous example, the sum of F is 120. So that's why we multiply by 120. So we look at the data that we need to locate where the data, then we may apply the formula here. Okay, so guys, yeah, that is all about 6.2. Okay. Alright, okay, so that's all about 6.2. Okay, so thank you for your attention. Thank you for your presence. And I hope that you can also prepare for UPS 3. Okay, but first you need to prepare first for UPS 2. Okay, so next Monday we will continue with 6.3. And then we are done with topic 6. Alright, so guys, again, okay, that's all. So thank you also Nob and Shamin for joining me. Okay, so for the rest, if you are interested to join me in the studio, so then you can let me know so that I can invite you lah. Okay, so that's all. Assalamualaikum warahmatullahi wabarakatuh and have a nice day everyone.
Baik, jangan lupa subscribe.